Hey, good morning. It's Monday. We're going to start into some factoring this week and breaking things down. So basically, we're going the opposite direction of what we were doing the last couple days. Okay, we've been using the distributive property to come up with a trinomial or something like that, and today we're going to start working on going backwards. Okay, so. If you took the test on Friday, you can swing by the school and pick it up so you can make corrections to bring that grade up 10%. If you didn't take it on Friday, we need to make sure that when you get back that you're ready and you take that sometime quick, okay? All right, so here's our warm-ups for the day. So pause your video and do these 5 problems and let's see how you did. Okay, let's see. Two numbers that are multiplied together, so the two numbers being multiplied or more, are all factors. Factors are things that will go into a number when I multiply them. So that's an important word for the day. And then check out your next 4 problems and see how you did. Okay. All right. So today, many things happening here. We're going to be writing numbers in prime factorization form. And then a lot of the focus is going to be finding this thing called the greatest common factor. And the greatest common factor, kids always get that mixed up with the least common multiple, LCM. We won't do this for a little while, but greatest common factors, I like to kind of think of numbers that go into. That go into a number. On LCMs, I like to think of it as skip counting. So when I do multiples of 2, I say 2, 4, 6, 8. And if I was on the multiples of 4, I would say 4, 16, how about 8, then 16, etc. And so if I'm looking for the least common multiple, in this case of 4 and 2, 2 and 4, 4 would be the least. So I'm looking for the least. Over here, I'm looking for numbers that go into. And again, that's a very important part. Okay, numbers that go into both of them. All right. So in order to do this today, we got to review a couple of things that we've studied in the past. Something that's called a prime number is very important. Prime numbers are only numbers that 1 in itself will go into. Like 2 is a prime number because the only way you can get 2 is 2 times 1. 3 is a prime number, even though they didn't list it, because the only way you can get 3 is 1 times 3. 5 is a prime number. 13, they missed 7. There's lots of them, okay? And so we will always want to break numbers down to prime, okay? Numbers that are not prime, we call those composite numbers. That's pretty important. So if it's not all the way broken down to just prime numbers, we call it composite. So like 4 would be a composite number because I can get 4 by 1 times 4, but I could say 2 times 2, okay? 6 is a composite number. So all numbers that are not prime are called composite numbers. And when we do prime factorization, that means breaking a number down until we have nothing but prime numbers. And so through your years, you maybe have been taught different ways to do prime factorization. I don't really care for this first one here. Usually when I teach it this way with making a factor tree. And I know some teachers here do this thing called a ladder method over here. And we'll do an example of both of them. What I like about the factor tree is, even though this person said 4 times 6, if I do 24 and I say, okay, I can do 2 times 12, even though I did it differently, I still will come up with the same answer. 2 and 6. And I usually circle when they're prime, so that means that the tree's already, that end of the branch is done. And if you notice, I still have 3 2s. There it is. And 1 3. So I just look at the numbers that are in the circles when I go to find my final answer. Okay, so let's go try a couple of them. They said find the prime factorization or write it in prime factorization form of 60. Let's use the factor tree. Okay, so let's just say 6 times 10, because I know 6 times 10 is 60. Now, neither one of these is prime, so I'm going to put a V underneath both of them because they're not prime. And I know 2 times 3 is 6. 2 is prime, and so is 3. And I'm going to focus on the 10 now, and I say 2 times 5 is 10. 2 is prime, and 5 is prime. So now when I go to write my prime factorization, I'm going to look for my smallest numbers first, which is 2. My base is a 2, and how many of them do I have? I have 2 of them. My next highest number is a 3, so that takes care of him. And then my last number is a 5. So prime factorization form should look like that. It's important that when you're writing prime factorization form, you put your smallest numbers base first, and you work in increasing order. Okay? Let's do the ladder method. I think they wanted us the same number. So the way the ladder method works is most of the time kids can divide by 2 in their head, and so half of 60 is 30. And so you just keep going by 2s until you can't, and then you think about 3. Can 3 go into it, etc. So half of 30 is 15. So now you see 2 doesn't go into 15, so we try in our head 3. Yeah, 3 goes into 15. And if I do 3 into 15, that is 5. And so these are all my numbers that will become part of my answer. Okay, so how many 2's do I have? I still have 2 to the second power. I have a 3, and I have a 5. All right, so that's how you do prime factorization. All right, so you give it a try, pause your video, and then come on back when you're done. Find the prime factorization of each of these numbers. All right, let's see how you did. 33 was nice and easy because 3 times 11 is the only way you can get 33, and 3 was prime and 11's prime, so my factor tree was kind of done. Again, I like to circle these. I don't know why I didn't each time my branch so that I know that branch is done. But I had 3 2's over there and a 5. All right. Now, when I'm looking for the greatest common factor, and this is what I was talking about, is I list all the factors as one way that they show here off the bat. As they say 1 times 12, 2 times 6, 3 times 4. I list all the factors, and as I look at all my factors, I'm looking for common ones. Common is 1. I have 2's in both. I have 4's in both, but I want the greatest common one, which would be 4 in this case. Now, it's our hope that we can do a lot of this in our head, and some of us can that know our multiplication facts really well. But sometimes they get a little challenging to find the GCF of 2 numbers, and if we accidentally say, like on 24 and 60, our greatest common factor is 2, well, we missed it because that isn't the greatest one. So let's do this one. Now we're looking at focusing on 2 numbers. Now I want to focus on, I'll show you one way if I list the factors, and then we'll talk about how I can speed this up. So if I want to list the factors of 24, what I do is sometimes if I want to list all the factors, I say 1 and I'll put 24 over here. Because 1 times 24 is 24. And then I'll say, okay, 2 goes into 24. 2 times 12 is 24. So I'm listing my opposite factor that I'm multiplying by at this end over here, and I work my way towards the middle. Then I'm kind of sure to get them all as fast as possible. So if I do 3, well, 3 will go into 24. That's 8 times. I know 3 times 8 is 24. I don't know what's happening to my screen here. 4 goes into 24 6 times, and so I met in the middle because I know 5 doesn't go into 24. So now I pretty much have them all. If you just start saying 2 times 2 goes into 24, 3 does, 4 does, there's a very chance that when you get down here you'll forget some of them. So let's kind of practice that with 60. I know 1, and I want to put this one way out here because I know there's a lot of factors of 60. 2 goes into 60, and I know half of 60 is 30. 3 goes into 60 20 times. Okay. 4 goes into 60 4 times 15. 5 will go into 60, and sometimes we'll have to kind of do a little multiplication thing. 5 times 12, if you don't know. Sometimes I'll get in the middle here and I'm running out of room because I know 6 will go into 60. 6 times 10. 7 won't go into 60. 8 won't go into 60. 9 won't go into 60, and I already have 10. So here's all my factors of 60. There's a ton of them. So now let's look for the greatest one. Well, my common ones is 1, I have a 2, I have a 3 in both, I have a 4 in both. Now I have a 6. Anything else? Nope, there's a 12. Anything else? 24. So it looks like my greatest common factor for 60 is 12. So when you write your answer, you say GCF, it's the fast way, greatest common factor is 12. Now sometimes when I do this, I'll just list the factors of the smallest number. And then I'll just keep asking myself, and I'll start high. Does 24 go into 60? No. Does 12 go into 60? Yeah. Because I want to find it as fast as possible. Okay. Again, if sometimes we can do that in our head, but 24 and 60 was a little bit of a challenge. Let's do it prime factorization way, and I'll show you how to do that to get your GCF. So let's make a factor tree of 18 real quick. 2 goes into 18 9 times. And this one will kind of help us on when we get to variables today. So this is a good way to work these out. Let's do 27. Prime factorization of 27 is 3 times 9. So 3's are prime. And so 3 to the third power is my prime numbers on these guys. So now what do? To find my GCF, I look for a common base, which is in this case 3. They both have 3's. This one has 2 3's in it, and this one has 3. So what I do is I look for the one with the smallest exponent. And in this case, it's 3 to the second. So 3 times 3 is 9. So my GCF for these two would be 9. I take the smallest exponent of the base that's common. Now, if I had something like this, let's just pretend when I did my factorization, I had 2 to the second times 3 to the third. And this one had a 2 times 3 to the second. Well, they both had a 2, so I would bring down a 2 to help me find my answer. And they both have 3's, and so I take the one with the smallest exponent, which would be 3 to the second power. So that would be, so here would be 18 would be my GCF if that was my case, because 2 times 9 is 18. Okay, so we can have more than one base that's common. Okay, all right. Let's go down and try it here now. Sometimes you can just do it in your head, a nice, easy one. And that's my goal. You don't have to make a factor tree for every single one. In fact, I encourage you to try to do it to get the greatest one that you don't have to do those. So again, what I do in my head is I start with 12, because I know 12 goes into 12. 12 doesn't go into 16. Then I go work my way down. What's another number that goes into 12? My next number down is 6. 6 won't go into 16. Okay, and then I work my way down. 4 times 3 times 4 is 12. 4 will go into 16. So my greatest common factor is 4. 4 will go into 12. 4 will go into 16. Okay. 15 and 25. I know the numbers that go into 15 are 1 times 15. 3 times 5. Those are my only numbers, and so the greatest one that will go into both is 5. So my GCF on that one is 5. All right. Okay. So I'll fix one on my paper over here real quick. All right. So hopefully you got 4 and 5. Yeah, I did. Okay. Now this is where it all comes together here. Now, so when we're determining the greatest common factor of an algebraic expression, what we want to do is we want to look at our coefficients here. And let's take our greatest common factor of 6 and 4. And so would you agree that 2 is the biggest number that would go into 6 and 8? So we take that one, and just like we were doing up there with the factor tree, I'm now going to look at my variables. I have an a to the second here and an a to the second here. So what that really means is if I broke this way out into kind of where I can look for my variables breaking up would look kind of like this. A times B times B times B. And my other one would be broken up into A times A times B times C. There's a little time sign in between those. And so now if I'm looking for common ones, well, they both have an A. Oops. I don't know why that can go. They both have an A. They both have another A. So I have 2 A's, and so I have A to the second power. And then I look for my B's. This one has a B, so does this one. This one has another B, so does this one. Even though this one has 3, there's only 2 that are common. And so I would say B to the second. And then as I look at my C's, well, this one has C's, but this one doesn't. So I can't say there's a common factor there, okay? These are all factors because I can multiply all these guys together. And so if I'm looking for the greatest common factor, I look for the variables with the smallest exponent. That's common. Okay, we'll write a rule here in a second. That was a lot to take in. So let's go over it again. I'm going to look at my 8 and my 12. What's the largest number that will go into both of these? Now, most kids will know the GCF. So I'm going to say GCF here because that's what we're finding, greatest common factor. So 4 is the largest number that will go into both. So 4. Now, once again, I'm going to look at my variables. So they both have a C, and I'm going to go in alphabetical order. This one has 4 C's, and this one has 3. 3 is the most. So I want to say C to the third. That's the most I can take out of both. Even though this one has more, if I said C to the fourth, this one would not have enough. Okay? So again, that's kind of very important. They both have D's. This one has 2 and this one has 4. So the most I can take out of both of these would be, C to the second, or D to the second. Oops. Having a hard time with my pens today. It is D to the second because that's the one with the smallest exponent. Now they both have E's as well. So I'm going to look at my E's. That's an E to the first, and that one's an E to the second. So E to the first is my highest. And you know what? I'm going to go back and fix that. I'm just going to put E because E is the same as just E to the first. All right. So this is my final answer. 4, C to the third, D to the second, E. Okay. So let's write just kind of the 2 rules of what I do. So step 1 is find the GCF of the coefficients. If you remember coefficient, C-I is the number in front of the letters. So we're going to do that first. And then number 2, for my variables, find common variables. And take the lowest exponent. For your answer. Okay? All right, let's give it a try. So step 1 said, find my greatest common factor for 24 and 32. And again, some kids can do that in their head without making a factor tree. And then look for our variables. They both have an M. Take the one with the smallest exponent. Okay, my light just went off, so do these 2 and I'll be right back. Okay, let's see how you did. I got 8m n to the fourth. So when I did I said 24, because I didn't know what the greatest common factor for 24 and 32 is. And so I just listed my factors of 24. I said 1 times 24, 2 times 12, 3 times 8, and 4 times 6. 5 doesn't go into it, so I here's all my numbers that go into it. So I started with 24 in my head. That didn't go into 32. 12 didn't go into 32. It was 36. I almost said 12. And I just worked my way down through all these numbers of 24 instead of making a factor tree or working with both. And then I came to 8. And I said, oh yeah, 8 goes into 32. So 8 was my coefficient number. And then m's, they both had m's. So m to the first was the smallest exponent. They both had n's, so I took n to the fourth. And even though that second one had a p, the first one didn't have a p. So I can't say they were common. Over here, a little bit easier. 5 is the largest number. 5 is prime. So if 5 goes into 10, well, then that's going to be our greatest common factor. All right. So let's move on now to factoring a polynomial. Now this is what we're going to need to be able to do often. And now we have 3 terms that we want to go through. So we're going to look at the coefficients for all 3 terms. And we're going to look at 6, 8, and 2. And we're going to look for the greatest common factor for those. Do you agree that 2 goes into all of those? This is the largest. So I'm going to put GCF over here. Okay. So now, actually, I'm not going to write GCF because they want us to factor it. So, sorry about that. I want to take out a 2. And now I'm looking at my variables. They all have x's, and the smallest exponent that's in all of them would be x to the first. Now, this is very important. This is why we needed to learn how to multiply polynomials. What I'm going to do now is I want to say 2. I need to be able to get back to this. So if I factored out a 2x times what would get me back to 6x to the third? Well, 2 times 3 gives me 6. That's what I needed there. And now x times what would give me x to the third? X to the second. Remember, we add exponents when we're multiplying. So that gave me my first term. Let's focus on my second term. 2 times what would give me 8? 2 times 4. So x times what would give me x squared? I need another x. Okay, and let's go to my last one. 2 times what would give me a minus 2x's? Well, I need to have a minus 1 there because 2 times minus 1 would give me a minus 2. X, I already have 1x, so x times nothing gives me my x, and so I'm done. And so when we factor our greatest common factor out, we need to now say, well, what's left? Okay. Take some practice. So today's homework, there's a lot of practice problems, but the leading coefficients are pretty small for the most part. So what's my greatest common factor for 9? 9 goes into both, so we're going to factor out a 9. I'm looking at my variables. I have x's in both, so I'm going to take the one with the smallest exponent, x to the fourth. They both have a y, so I'm going to take out a y. Now I need to decide what am I going to multiply to get back to it. So 9 times 1 is 9. I'm not going to put a 1 there. X to the fourth, I don't need any more x's, but look at my y's. I need another y, don't I? Because y times y would give me back to my y to the second. Okay, so my first term in my binomial over here is going to be that. Now let's go to my second term. 9 times what is a negative 9? Well, I need a negative 1 for sure. Before I write a 1, I want to see if I have any x's. Yep, I do. I already have 4, but I need 6. So I need 2 more. So I'm going to say x to the second. Y's, I already have 1, and that's what I need is 1. So there is my final answer for that one. All right. So without the little extra circle around my screen, that's how we factor. That would be my final answer. I'm all factored out. Okay? That's a lot. So let's go ahead and talk about this now. This is when we kind of are reducing fractions, algebraic fractions. Simplify means to keep doing all the work until you can't do any more. Now, earlier this year, we said when we were trying to isolate variables, we could say we could write a 3 under this whole thing if we wanted to. That really means everything over here divided by 3. Now's a good time to kind of say, okay, well, that really means something like this. Okay, the 3 is really under everything. And so over here, we say 3 divided by 3 is 1. One of these things called p. And then we still have a 3 divided by 3 here, which is 1. So our final reduced algebraic fraction there would be a p plus 1. Okay. Now over here we have 5x. I want to say minus 25x squared. And this is really over 5xy. And this is still over 5xy. That 5xy is underneath both of those terms. Okay. Now over here we say 5 divided by 5 is just 1, so they cancel each other out. My x divided by x is just 1. Now I gotta have a 1 in the numerator up there. I just can't leave it blank. And I don't have any y's to cancel out, so it's just going to be 1 over y. Let's reduce my 25 fifths. Doesn't 5 go into 25 5 times? And so my 5 is going to be in the numerator. Let's talk about my x's. Now, a lot of times what I'll do is, like we were talking about before, I have x's in both. I have more x's on top. So one of these x's will cancel out with one of those x's, leave me with an x to the first on the top. And then I still have some y's in the bottom here, then no y's on the top to cancel out. And so that guy is my simplified fraction there. Okay. All right. So there's a lot to take in today. Now, here's the science stuff that we keep coming up with that we're going to be doing, word problems, and we're getting to where we can start solving these problems. Okay, so they said, here's this math problem, h equals that, there's that minus 16 that Fisher keeps talking about. That's gravity pulling down on an object. And it says, can be used to represent the height of an object that's launched into the air 12 feet off the ground. There's the key right there. We're already starting with 12 feet off the ground. Here's my velocity, 72 feet per second. So every second I'm going 72 feet. So if I went 1 second, 72, 2 seconds. So, okay. And rewrite this formula, factoring the right side using the GCF. Now, these numbers here, 3 numbers, we're going to use these often. And you see how that first term is a negative? So we really want to try in quadratics to make our first term when we're factoring. We want to, if it's a negative, and a lot of times it is, we want to try to factor out a negative. Okay, you'll see why later on, but just trust me on this one. So to keep well, let's figure out what number can go into both 16, 72, and 12. I start with 12 because that's my smallest number of the 3. I know 12 can't go into 16. Who cares about 72? If it can't go into 16, 12's not it. So if I list my factors of 12, 2, 6, 3, and 4. Does 6 go into 16? 6 doesn't go into 16. I can do that in my head. So I don't even care about 72. Does 4 go into 16? I know it goes into 12. I know it goes into 16. I'm not sure if it goes into 72, so I'm going to take 72 and divide it by, what I say, 4? Bam, and it does. So my numeric number is a 4. 4 will go into 16, 72, and 12. But my first one's a negative, so I want to factor out a negative 4. Okay? That will leave me with my remaining as a positive trinomial. Okay? Again, it'll make sense here in a second or another day. So we're going to factor out a negative 4 in order to make it positive. Okay. Now let's go with what's left. Can I do any t's? T's are not in all 3 of them, so I can't factor out a t. So the only thing I can factor out is a negative 4. So negative 4 times what would get us back to negative 16 t's? I want to need a 4t squared. Okay, Now I need to get back to a 72. So negative 4 times, and I saw that in my calculator I had 18. I need it to be a positive, so I know negative times negative has to be a positive, and 18 t's would get me back to 72 t's. And then my last term, negative 4 times what would give me a positive 12? Well, it has to be a negative because a negative times a negative is a positive, and that one's going to be a 3. All right? So, very important that we factored out a negative 4. We'll factor this guy down some more yet. But right now, I'm just happy if you can get the greatest common factor out of there. Okay? Because that last part, second part, can be factored more, and we'll start that on Wednesday. How do I break that guy down? Okay? Let's do it in baby steps. Today, we already did a whole lot. All right, so give it a shot. Again, there's that quadratic equation that has a negative 16. So I know this is kind of like a science question. Something's going up into the air and being pulled back down. I also know that it's already 4 feet off the ground. Okay, and I know its velocity is going 60 feet per second. All right, so factor that guy out. I want the largest number that goes into 16, 60, and 4. I start off with 4. Because I know 4 goes into 4. Hey, look, 4 goes into 16 as well. Does 4 go into 60? Sure, but I'm not sure how many times. 15 times. I did know that. I just wasn't thinking yet. So again, because our first term is a negative, try to factor out a negative 4. Okay? Can't take a t out of everything because there's only t's in the first 2, not all 3. So write what you got left and come on back. All right, here's what I got. T squared minus 15 minus 1 is inside the parentheses. Okay? All right, so when you go to your paper today, you can see some of these numbers are pretty crazy. 68 and 34. Some of them are not the real obvious ones. Okay? So, again, try to make I picked the 34s, and I might list all the numbers of 34. Make a factor tree, maybe. I know 2 times, and I'll do on my calculator, 34 divided by 2, 17. Does 17 go into 68? I have no idea. It does. Nice. Well, did 34 go into 68? Duh. 68 divided by 34, yeah, 2 times. Duh. All right, so 34, my GCF is 34. That wasn't so bad. But now this 55 and 75. What do you think is going to be on that one? 55 doesn't go into 75, so again, I would do this over here, 55. 2 doesn't go into, 5 goes into 55, so that would be 11 times. Does 11 go into 75? No. 6 won't go into, 7 won't, 8. So I'm thinking this one here is just going to be 5. So my GCF on this one is going to be 5. Yep, you must write GCF. Let's do one where we have some variables here. Let's do number 7. What's the largest number that goes into 18 and 54? Pretty sure 18 goes into 54. Sure does, 3 times. So my GCF on this one is going to be 18, because 18 goes into 18 and 18 goes into 54. And they both have a y squared. So that one's not too bad. Maybe they just look bad. All right. All right. Let's go down and do one factoring a polynomial. Which one you want to do? 9? Let's look at number 9 right here. The largest number that goes into my coefficient of 3 and 6 is going to be a 3. Oops, they want us to factor it, so that means we're going to have a multiplication problem hereafter. So 3 goes into both. Now let's look at the variables. I have an a squared and an a to the third. I want to be able to take 2 of them and b. So now what do I have to multiply to get back to it? -1 for sure. And that's it. Because I have enough a's and I have enough b's. Now 3 times what is 6? 2. How many a's do I need? I need another a. and I need another b. So I need that -1 there, because -1 times this is going to get me back to that. Okay? Try boxing your answers so that it makes it easier for me to grade. Okay? I got a lot of papers. Let's go down and just do one more real quick. Let's do number 15. I'm looking at my coefficients. 15, 35, and 20. I go with my lowest number, which is 15. Again, in my head, I'm thinking 1 times 15, 3 and 5. So those are all my factors of 15. So I start with the largest one. 15 won't go into 20, so I don't go any further. 5 will go into 20, and 5 will go into 35. So I want to take out a 5. Let's look at my x's. X to the 8th, x to the 5, x to the 3rd. Let's take out an x to the 3rd. Now focusing on my y's. Yep. They all have y's. 3, 2, 2. Take out y to the 2nd. Now I want to focus on my z's. They all have a z. So I'm going to take out a z because z is the smallest exponent. Now what do I have to multiply to get back to it? 5 times 4 is 20. I need 5 more x's. Don't need any more y's, but I do need another z. Let's go to my second term. What do I need? 5 times 3 is going to give me 15. Do I need any more x's? Yep, I need 2. Do I need any more y's? No. Do I need any more z's? No. First and 2 of the y's, so they're all covered. Let's go to my third term. It's going to be a plus 7, because 5 times 7 is 35. Don't need any more x's. I do need one more y. And I don't need any more z's. Bam. It's going to take a lot of concentration here today. Homework today is going to take a little while. Okay? All right. You get better at it with practice. Okay? All right. So give them a shot. It is a lot of work today. I think I got 30 of them. I think I might have cut them off a little bit on your practice sheet. All right. Practice. All right. Sometimes you won't get the largest one the first time, but start recognizing it. Okay? All right. We'll see you tomorrow.